Students, today we are going to discuss about output power characteristics of a wind turbine. What is output power characteristics of a wind turbine? For the output power characteristics of a wind turbine, I'll take wind speed on x-axis and wind power on y-axis. I'll take the response of power output with respect to a wind speed. The response will be like this. Okay, the response will be like this. So this particular speed is called cut-in speed, which is in the range of 3 to 3.5 meters per second. 3 to 3.5 meters per second. What is actually cut-in speed? Cut-in speed is the speed, minimum speed, below which the total power output is equal to 0. Why the total power output is equal to 0? Maybe wind turbine is unable to overcome that inertia, and that may not be sufficient to able to drive your electrical generator. So below 3 meters per second, the total power output is equal to 0. So later what happened? So wind power output is equal to, the formula is half rho a v cube, half rho v cube. So it is proportional to cubic of a wind speed. It increases like this till at particular point. So here power reaches maximum value. So power reaches a maximum value. What do you mean by maximum value? Maximum value or rated value means this particular wind turbine is coupled to a generator. This particular wind turbine is coupled to a generator via gearbox mechanism. So that particular electrical generator rating is 2 megawatts, for example. It reached to a 2 megawatt. Then what happened? It will not go beyond 2 megawatt. So whatever may be your wind speed beyond that value, then automatically your gearbox is adjusted and the maximum power value is maintained. So this is called the rated. Then what happened after the rated speed? Then what happened after the rated speed? Still, if the wind speed increases, then what happened? It has to increase, right? Your wind power output is equal to half rho v cube. If the wind speed increases, then your power output has to increase. At least it has to maintain the rated value, but it is going to be 0. It is reaching to 0 after a particular wind speed, let's say at 25 meters per second. So let's say at 25 meters per second, this is called the cutout speed. Then what happened? Cutout speed is the speed beyond which the power output is equal to 0. So power output is equal to 0 below 3 or 3.5 meters per second, your cut-in speed, and again power output is equal to 0 after cutout speed. Why power output is equal to 0 at cutout speed? What is the reason? The reason is mechanical damage to your wind turbine. What do you mean by mechanical damage to the wind turbine? So let's say 25 meters per second is your cutout speed. 25 meters per second is roughly 90 kilometers per hour. 90 kilometers per hour is a huge wind speed. Sometimes it happened at the time of cyclones. Hudud happened maybe in 2015 in Vizag. At that time, because of that time, 90 or 100 kilometers per hour, sometimes more than 100 kilometers per hour, the mechanical damage to your wind turbine. So that is the reason why generally we will adjust the wind turbines in the direction of wind flow, but at that time we will adjust in the other direction or otherwise. So we will adjust in such a way that there will not be any wind flow to the wind turbine, so that we can save the wind turbine. So this is the cut-in speed, rated, and cutout speed. This is about wind power characteristics of a wind turbine.